Okay, hello everybody, Algebra 1. We are in section 9.2b, which is graphing quadratic inequalities. So this is going to be a lot like graphing um, regular quadratic equations, again with just a couple slight differences. Remember when we graphed linear inequalities, we had to use a dotted or a solid line based on whether it was um, greater than or less than, or greater than or equal to, less than equal to. And then we had to shade on one side using the test point. So everything's the same as back in 9.1 when we graphed, except for those last couple steps. So let's go through those steps again. Remember, we're looking at now y, instead of y equals ax squared plus bx plus c, we're looking at y is less than or greater than. And it could be an or, less than or equal to, greater than or equal to. So that's the big difference here. So the first thing we're going to do is we're going to put the vertical axis of symmetry on the graph, just like we did before. And remember, that's x equals negative b over 2a. If we don't know how to do that yet, then we're in some problems. We're in some trouble there. Okay. Then plot the vertex. This is the point xy on the axis of symmetry. So doing that axis of symmetry gives you the x coordinate, and then you got to plug that into the equation to get your y, which was something we've done many, many times. Then we're going to plot the y-intercept, and in this case, remember, that's your c value. And remember, you can also use a mirror image point from that. So once you have your axis of symmetry and your y-intercept, if you use the mirror image point on the other side of the axis of symmetry, then you've got another point there for you. And then you've got to plot the solutions if you have them on the x-axis. Remember, these are your x-intercepts. That's where they cross. And then basically you have to maybe find additional points using an x, y values table if you don't have at least 5 points from above. So somewhere in here, in steps 4 and 5, you have to decide, do we solve? Or not. Okay? Somewhere in there, in steps 4 and 5, we have to decide, do we want to solve it or do we not want to solve it? Okay? Solving meaning that you can factor it if you can factor it. If you can't factor it, then you might need an XY table, or if it's harder to factor. If you can factor it, then boom, you've got your x-intercepts, you've got some points. Remember, we want at least 5 points. So if you don't have 5 points, then make an XY table and get yourself 5 points. But between your vertex, that's 1 point. Your y-intercept would be 2. You could use the mirror image of that for 3. And then if you factored it and got 2 solutions on the x-axis, that'd be 4 and 5 points. But if you don't have that, then go ahead and plot them. Okay? The next one, decide if it should be a solid or dashed line. Remember, if it's a solid line, if it's this or this. Let's put that over here. Solid line if it's this or this, and then a dashed line if it's this or this. Okay, so understand that, just like we did with linear equations. And the last part then is test a point to shade inside or outside the parabola. Don't think of it as inside or outside the parabola. You should think of it as either on the test point or not on the test point side. So, and again, use 0, 0 if possible. And remember, the only reason you wouldn't be able to use 0, 0 is if the parabola went through 0, 0. So 0, 0 is the easiest test point. But if that is on your parabola, then you have to pick a different point to test. But 0, 0 would be the easiest one, especially with quadratics when there's more than one x involved. Okay, so let's get to some examples here. All right, so the first one, graph and shade y is less than or equal to negative 3x squared plus 1. All right, so there is no b value here, so I automatically know, and I try to do negative b over 2a, there's no b value, b is 0, so that I know my axis of symmetry is going to be 0 right off the bat. I also know then that means my x coordinate of my vertex is 0. And then I can plug in 0 into this x here and get my y coordinate. Well, if I do that real quick, 0 squared is 0, times -3 is 0, so 0 plus 1 gives me a 1. So I know my y coordinate would be 1, okay? Y coordinate would be 1. My y-intercept, well, that's my c value. That's right over here, my c value. So my y-intercept is 1. All right, now solutions. This does not look like it's going to be fun to factor, okay? So if we take a look at it, we might not be able to factor it. But what I have right now, if I just plot the points I have, I know my axis of symmetry is x equals 0, so that's the line, dotted line right through the y-axis, right where x is 0. And I got a vertex at 0, 1, so 0 on x, 1 on y, so there's my vertex there. My y-intercept is 1, that's already there, so it didn't help me, and I really can't use a mirror image point. So I need some solutions. I need to be able to factor this or use an xy table. Factoring doesn't really work out for us here with this example. So let's go ahead and use our xy table. And we need 5 points. Right now we only have 1, so we need a bunch of different points. I'm going to put my vertex in the middle, 0, 1. And then I'm going to go ahead and pick 2 values that are below 0 and 2 values that are above 0 to get my 5 points. And I just have to plug them into the equation here. So when I do that, I've got a -2 that I plug in here. So when I do that, I'm going to get -2 squared is 4, times -3 is -12, plus 1 equals -11. So now I know down here I've got -11. Okay? Let's plug in a -1. If I do that, -1, plug it in here. -1 squared is 1, times -3 would be a -3, plus 1 would give us a -2. So that would be -2 down here. I already have 0, 1 done. That was my vertex. 1, when I plug in 1, you kind of see you're going to get the same result here. 1 squared is 1, times -3 is -3, plus 1 gives me a -2. And you're kind of hopefully seeing the symmetry there between 1 and -1. They both have the same result of -2. And then when I plug a 2 in there for the last thing, for my last point, if I plug a 2 in here, 2 squared is 4, times -3 is -12, plus 1 equals -11. So my y value then would be -11 down here. And again, I hope you can see that symmetry between 2 and -2. They have the same y value. So now I got 5 points to plot. Let's go ahead and plot those. I already have my vertex done, -2, 11. Go -2 on x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, just off the map there. -1, 2. I can do a mirror image point here and put me at 1. Oops. Oh, my bad. Yeah, good catch. Good catch. I'm going -11. -11. That's going to change things. Whew, that was a close call. So I'm at -2, -11, down 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That puts me here. -1, -2. -1 on x, down 2. Now I can use my mirror image point. I should be +1 down 2. I have a point here. And I should have a point down at -11 as well. At +2, -11. So there's my graph. If I go ahead and sketch that, and just continue those arrows, here's what I have. Okay? Now, by looking at this, the last thing we have to do, the last two things, decide, is it a solid line or a dashed line? Now, I already made it solid. And sure enough, yes, it is a solid line. Because of this sign here, it's an or equal to. So that means it's a solid line. So good thing I already made it solid. If I screwed that up, I just have to go ahead and dash that. And now the last thing is pick a test point. Remember, 0, 0 is the test point we want to pick. Can we pick 0, 0 on this one? Is 0, 0 on this graph? Technically, no, it's not. It looks real close, but it's not because that's 0, 1. So 0, 0 we can use as our test point. So if I take the original equation, oops, let's put x in there instead. So when I get the whole original equation, just remember we're testing. Okay, and plug a 0 in for x and a 0 in for y. Okay? What we're going to get here is 0 squared is 0 times negative 3 is also 0. So I have 0 plus 1. So my statement would say 0 is less than or equal to 1. Is that true? Why? Yes, that is true. So we got a true statement, which means we're going to shade where 0, 0 is. Don't think of it as inside, outside the parabola. We're going to shade where 0, 0 is. In this case, 0, 0 is inside the parabola, so we're going to shade all of this stuff. And we can touch the line because it's an or equal to. And all that stuff would be shaded there. Okay? So simple as that. As far as just like we did with inequalities in linear equations, the same thing. Everything's the same graph in it, then you just got to pick a test point and decide if it's solid or dashed. All right, let's do one more. Let's skip ahead to number 3 here. Graph y is less than 1/2 x squared plus 2. Okay, so first thing we're going to do is, and we can also think this is kind of in vertex form already, so kind of use that to your advantage if you can, because again we're going to have x equals 0 because there's no b value, and then you should be able to figure out that your vertex then would be 0, 2, because if we put this in vertex form, we would look at a times x minus h squared plus k, and remember your vertex is always going to be h and k. Well, since there isn't an h here, that would be 0, and then your k value is the same as your c value too, so your vertex is 0 too. So sometimes vertex form helps for that. Your y-intercept is also 2. And then solutions here, again, this one's not a very fun one to factor, so let's go ahead and make an xy table. Because again, if we look at this, my axis of symmetry is x equals 0, so x equals 0 is this line here, a vertical line through 0 on x. And then we've got a vertex at 0, 2. So that puts a vertex here. That's also our y-intercept, so I don't really have a mirror image point that I can use, but xy, I can use an xy table to do that. So again, I'm going to put my vertex here, 0, 2. I'm going to use 2 values below that, 2 values above that. And again, don't get carried away with just always using -2 to +2. It depends on your vertex. Go a couple above, a couple below. Now when we plug in these numbers here, -2. A little trickier with fractions here. But if I plug a -2 in here, -2 squared is 4. 4 times 1/2 is 2. So I'd have 2 plus 2, which is 4. If I plug in a -1 here, -1 squared is 1 times 1/2 is 1/2, plus 2 is going to give us 2.5. I put 2.5 in. And 0, 2 we already have. If I plug a 1 in, you should get the same result as when you plugged in a 2.5, or when you plugged in the -1. So 1 squared is 1 times 1/2 is 1/2, plus 2 is 2.5. See that symmetry? And then I plug a -2 in, I should end up getting 4. So it's symmetric. But let's just double check and make sure. Plug a 2 in, 2 squared is 4, times 1/2 is 2, plus 2 is 4. Okay, so we got enough points now. Let's go ahead and graph them. -2, 4. Back 2 on x, up 1, 2, 3, 4. -1, 2.5. Backwards 1 on x, 1, 2.5 puts us there. And I can use mirror image points to 1, 2.5, and 2, 4. And there's my points. Let's go ahead and graph that one. Remember, it should be a little bit wider because it's a fraction. Remember that. And now we can use our test point. Can we use 0, 0? Yeah, because 0, 0 is here. It's not on that line, on that parabola. So we can go ahead and use 0, 0. So let's take a look at the original equation again. Y less than 1/2 x squared plus 2. And now I plug in 0 for each x and y. And remember, if there's another x, if there's a b value, you have to plug in 0 for that one as well. So here I've got 0 is less than 0 squared is 0 times 1/2 is 0 plus 2. All right? And so that means 0 is less than 2. Is that true? Sure is. That's a true statement. 0 is less than 2. So again, it's not about inside or outside the parabola. This one comes up to the idea that it's going to be where the point 0, 0 is here. So since it's true, we're going to shade that part. One thing that we forgot to do is is it solid or dashed? Well, this one's going to be a dashed line because of it's not an or. So I'm just going to go ahead and get rid of some of the lines, just make it dashed. Okay, the best I can. I'll just kind of do that one. So it should be a dashed line. And then we're going to shade everything on the 0, 0 side. And I'm actually not going to touch the line here because it's not or equal to. So I'm going to get as close as I can without touching it. But all this stuff here should be shaded. So in both of our examples that we did, they were both true, but one shaded inside the parabola, one shaded outside the parabola. So again, it's not about inside or outside the parabola. It's about where the test point is, and if it's true or false is where you shade. Okay? And then just remember dashed or shaded. All right, that's it. Bring us to the lesson summary and explain in your own words how you know where to shade a quadratic inequality, what side. And then the last thing, the practice problem here, is if you did graph this, I'm not saying you have to, but if you did graph this, would the parabola be dashed or solid? Why or why not? Or why, basically. And then if you could use a test point 0, 0, would you get a true or false? So you're just kind of telling me dashed or solid there, and then plug it in, would you get a true answer or a false answer? Okay, that's it for today. Let's be ready to rock and roll tomorrow.